Okay, so here we want to write the decimal expansion of 4/9. And of course, all that really means is to write this fraction as a decimal, right? To write the decimal representation of it. So how do you do that? Well, the basic approach I take, at least, here is to find what 1/9 is and then multiply that by 4, right? Because here we have what? Well, we have 4 over 9, and that really, of course, is 4/9. So what I'm going to do is find 1/9, right? That's going to equal some decimal, and then take that result, whatever this is, right, and then multiply that by 4, and that will equal our decimal expansion, right? And that's one way to do it. Another way to do it is just to take 4 and divide that by 9. I'm going to right, you could do 4 divided by 9, and that would give you the same decimal expansion, right? I'm going to take this approach right here because there's a nice pattern to build off with the ninths, and I think that becomes more obvious when we find 1/9 first. So how do we find 1/9? Well, the same way we divide numerator 1 by 9, denominator. That's a general algorithm I use for almost all fraction conversions when I don't know the decimal equivalent. So if you don't know the decimal equivalent of 4/9, then you would divide the numerator by the denominator. So how do we do that? Well, we get into a little bit of long division, right? 1 divided by 9. So the first question is, how many times does 9 go into 1? Well, it doesn't. So think of 1 as 1.0 or 10. Now you can ask, well, how many times does 9 go into 10? Well, the answer is once, but really it's 0.1 if you think it's proportional, right? 9 goes into 10 once evenly, so it goes into 1.0, a number 10 times smaller, 10 times less, right? Just, I'll show you this real quick. If it was 10 divided by 9 equals 1 with some remainder, then 1.0 divided by 9, right, should equal 0.1 with some remainder. That the reasoning here is, oh, well, 10 is 10 times larger than 1, so if we divide them by the same number, we should get a result that's 10 times smaller than our original, right? 10 divided by 9 is 1 and something. 1 divided by 9 is 0.1 and something. That's anyway, so this whole logic is something you use throughout long division, right? The proportional relationship amongst these types of division problems, how they're connected. Anyway, so 9 times 1 is 9, and now you want to find the remainder. So think of this as 10 minus 9, which is 1, and we're back in the same position. How many times does 9 go into 1? Well, it doesn't. So add another 0, drop that down, and now you find how many times 9 goes into 10 again. And the answer is 1, right? And here it's not really 10, of course, it's 0.1. So you think if we continue this pattern, instead of 1, if we have 0.1 divided by 9, it makes sense that 9 would go into 0.1 times with some remainder. Right, we're just following this pattern, 10, 1, 0.1, and so forth, so the quotients also follow that pattern. And this will keep happening. You might see here that this is going to be a repeating decimal. 9 goes into 10, right, once again, right? So 9 times 1 is 9. We subtract, and we get another 1. In fact, there's always going to be another 10 left over. So here, 1/9 is 0.1 repeating, right? So 0.9, oops, sorry, 1/9 equals 0.1 repeating. So then if you double that to 2/9, we get 0.2 repeating. And you might see a pattern here. With 3/9, that's 1/3, right? We get 0.3 repeating. And we keep going. If we have 4/9, we have, right, 0.4444, right, or 0.4 repeating. And that's our decimal expansion. And one of the nice patterns here is to realize that when you have ninths, you're always going to have a repeating decimal, and the numerator will always match the decimal that's being repeated. So 1/9 has 0.1s repeating, so it repeats the numerator over and over again. 2/9 has 0.2 repeating, 3/9 has 0.3 repeating, and so forth. If we had 7/9, right, just as an extension of this, what would that be? Well, that would just be, we'll look at the numerator, it's 7, so it's 0.7 repeating. Just one of the many nice patterns with ninths. Alright, hope this helped.